Hi, this is Masti Badi for HAP 501 at George Mason University, and I'd like to show you how to use Excel to run an ANOVA test. Here we have data from stress levels of 15 patients. The patients were randomly assigned to 3 different groups. One was given music therapy, one relaxation therapy, the other neither therapy. We've measured their stress levels on a scale of 1 to 10, and we'd like to see whether the 3 groups are the same or different. In other words, we want to run a test of equality of means for 3 groups. So in order to use Excel, we need to go under Tools and choose our Data Analysis option. Here it is. And then here we need ANOVA single factor. Why single factor? Because we only have one dependent variable, the stress level, and the 3 categories of the independent variable, whether they receive therapy or not. Okay, anyway, this is the ANOVA single factor dialog box. So you need to choose your data. The data range is, all your data here. Grouped by columns. If it was grouped by rows, you need to tell Excel. Also, you need to tell Excel whether you're including labels in the first row or not. The alpha level of 0.05 is fine, we'll keep it. Output range, we would like to put our output right here. Say OK. And here are the results of your single factor ANOVA. Excel will give you a summary of the 3 groups. It'll count them, give you the sum for each group, the average for each group, and the variance of each group. And then Excel will give you the results of the test of one-way ANOVA. So Excel gives the result in form of source of variation. It's divided the source of variation into between group and within groups. So it's going to give you the value for sum of squares and the value for degrees of freedom. And then it also gives you value for mean square for both groups. Excel provides the totals for sum of square and for degrees of freedom. And then it gives you your calculated F value, your P value, and very nicely provides the critical value for F2. So you can compare your calculated F, your test statistic here, which is 9.13, and is greater than your critical value of 3.88. So that tells you something's going on. You can't accept the null hypothesis. You can't just carry on with it. Also the p-value. Every time you see a p-value that's smaller than your alpha, here it's 0.003, smaller than 0.05. So that tells you there's something significant. If you have a p-value that shows significance, that means the status quo cannot hold. You can't accept a null hypothesis. You can't just carry on with it. You have to reject a null hypothesis because you have a significant result. However, based on Excel, you don't know what the result was. You know that the 3 groups aren't equal, but you can't tell from an ANOVA test which one of the 3 groups aren't equal. It could be that there was a significant difference between music therapy and relaxation therapy. It could be that there was significant difference between control and music therapy, but not between control and relaxation therapy. You can't assume any of that based on the result of an ANOVA test. In order to find that out, you need to conduct further testing. However, based on your statistics here for a one-way ANOVA test, you can reject the null hypothesis and reject the assumption that these 3 groups have equal means. That's it.